Alright, hello, welcome to episode 2 of our actual physics stuff. So, I'm going to start off this episode with talking about Newtonian Mechanics. And so we're going to start that off with Newton's laws. So, hopefully you remember Newton's laws. The first one is things in motion stay in motion, right? So, things in motion stay in motion unless acted on by by an external force. 2 is change in our velocity is 0, and here we have F equals ma, right? So the force is equal to the mass times the acceleration of that object, and the third one is, well, the net force. The sum of net forces is 0. For every action, there is an equal and opposite reaction, right? So, I'm just going to talk briefly about how what we've talked about applies to Newton's laws. So let's think about F equals ma. Well, we've already described that this is actually m r hat double dot, right? Or alternatively mv dot, right? And mv dot, well, we know that momentum is m times velocity, so mv dot, this is actually momentum, the change in momentum. So we have this equivalent expression: F is equal to the force on an object is equal to the change in its momentum, right? Very, very brief. And then next thing I want to touch on is differential equations. If we actually rearrange this, so we have r mr equals F, we can rearrange this equation in terms of r. And what do we find here? Well, we have this is a second order ordinary linear ordinary differential equation, right? That makes sense. Pretty cool. So what does that, so how can we solve this? Well, we can, we find velocity, and then this is going to give us, okay, v naught plus well, we want to go from, obviously, I'm going to take this integral from 0 to t of r s double dot ds equals 0 t of f over m t, or not t, but s ds. This is going to give us our velocity t minus our velocity at 0. So this is actually our initial velocity, right? Is equal to this expression here, F force over mass at some time. And so we can solve that. We get, okay, our RT equals V naught plus, or we should make this a bit wider, plus F of T over M. And then obviously, and then we can do this one more time, and we can solve R naught plus V naught T plus 1 over 2, and I forgot a T here, 1 over 2 F of T over M T. And I'm actually going to use naught sum m F naught t times t. It's better to do that because here we're going to be assuming if we know some force, right? We know the force on this object is constant, right? Moving up, this is no longer going to be that. This is just going to be f of naught, right? So sorry for that confusion. Right, and so we can solve this differential equation for r, and we get this nice equation. And yeah, it's kind of pretty much it. Not too much else for Newton, I think, right now. We'll talk. I'm going to talk about inertial frames in the next episode.